Hi, today I'm going to show you how to use the regression feature on Desmos. So the first thing you want to do is go to Desmos, and if you want to do a regression, there's a little question mark help button up in the upper right hand corner. If you click on that, you're going to see a tour called regression. When you do this, it takes you through a little tutorial. Also, just be aware of this question mark. There are a lot of different places that you can get information from Desmos, so feel free to explore these tours. They'll be really helpful as you progress through Desmos. So let's click on regression. And when we do that, the first thing you do is you see these little information bubbles that take you through a little tutorial. So first we're going to get some data. We're going to head over here to Google Docs and we're going to copy and paste the sample data. Now, if we click on the sample data, what we're going to get is a Google Doc that opens up and it gives us some data. So you can have this in a spreadsheet that you can provide your kids. You can create a spreadsheet with data for your students, but right now, Google has provided it through Desmos. So we're going to grab what Desmos gave us. We're going to copy it. And we're going to go back to our Desmos screen and we're just going to paste it right in here. When you do that, it automatically creates a table for you. And you can see over here in the data points that it's shown up in our graph. So we can also click here to add an item. So again, the tutorial is bringing us through how to make this regression. So the first thing in the regression is first add your table with data points. Then we're going to add an item and we're going to select expression. So once you have your table with your data points and you've graphed your data points, you need to look at those data points and decide, do those data points look linear? Do they look quadratic? Do they look exponential? And then we're going to fit a model to our data. You can see here that Desmos is suggesting we do a linear model. So to do that, we're going to type in y1. If you type in y1, the 1 automatically becomes a subscript. And then instead of equals, you need to use the tilde or the little squiggle, which is to the left of the number 1. So you have to hit shift and you hit that button to the left of the number 1. That automatically tells Desmos that you would like it to perform a regression on the data that you have. Now we're going to type in mx1 plus b. Now the reason you need to put the subscripts y1 and x1 in is because then Desmos goes straight to the table and uses the data from that table because you've told it to here. Now, Desmos is telling you to check the residuals. The residuals are something you may or may not do in class. The closer those residuals are to 0, the better. And you can see that the residuals are relatively close to 0. So that's not bad. Now here Desmos is suggesting, well, maybe we could try a different model. So they're saying edit this equation. We could also just make another one. So instead of editing the equation they provide to us, I'm going to add another one. And I'm going to add a quadratic rather than this quadratic they're suggesting because the quadratics you do in class might look more like this. y1, and then we're going to use the tilde, and we're going to do ax1 squared plus bx1 plus c. So this is the standard form of a quadratic, and you can see what we've done here is we've created a quadratic regression using the exact same data, and if we turn this linear regression off, you can see that the quadratic regression actually fits the data much better than the linear regression that we created. So just to compare and contrast, there's the linear regression and there's our quadratic regression. And if you look at the quadratic regression, if we plot those residuals, you see those residuals for our quadratic are much, much closer to 0. Again, you might not do that in your class, so we can get rid of those residuals just by going up here and deleting them, and then they'll be gone. What you might actually look at in your class, which might make a little more sense, is the correlation coefficient, which are your r and your r squared. Remember, the closer your r squared is to 1, the better your regression. So if we compare these two r-squareds, the r-squared for our linear regression is 0.9529, which is very good. But if you look at the residual for our quadratic regression, or r-squared for that one, it's 0.9996, which is much closer to 1, which means that quadratic regression is actually a much better model. So if we were to decide between the linear and quadratic, we would use the quadratic. I hope this video helped you understand how to use Desmos to do the regressions. You can do any sort of regression using Desmos. You just need to follow these patterns as you put in your models.